So let's try a few problems on friction. Okay, so problem number 1 goes like this. Determine the maximum acceleration of the train in which a box lying on its floor will remain stationary. Given that the coefficient of static friction between the box and the train's floor is 0.15. Okay, this is the given question. Now see, since we are talking about acceleration, see, acceleration is given by what? It's the force, correct? So force is nothing but mass times acceleration. So in the friction formula, if we apply that, so what you get, so friction formula was F, whatever the force you have, so the frictional force we call it, right? So frictional force Fs is less than or equal to mu s into n. Remember, mu s is coefficient of friction. So in this case, see, we are talking about the force and we are talking about the frictional force, correct? So we have m into a is equal to Fs, which is less than or equal to mu s into n, right? Now see that mu s into n, see the normal, right? The normal. See, normal is what? It's nothing but, see, weight is downwards, so your normal is upwards, correct? Equal and opposite reaction. So since it is equal and opposite, the normal will also be the same as weight, which is m into g, correct? M into g. So in our case, we'll get, so the acceleration A is less than or equal to mu s into g. Now, okay, let me explain how we got this. See, acceleration, we are talking about the force, right? Force. M into A, which is nothing but Fs, right? But what is Fs? Fs is less than or equal to mu s into n, right? So as you can see in the formula, everything is there. Now, since n is nothing but m into g, so we have m into A less than or equal to mu s into m into g. Mm gets cancelled, so you have A less than or equal to mu s into g. That's how you get this formula. Okay, now mu s we know, g we know, substitute. If you substitute, you will get 0.15 into 10, correct? Because take 10, okay? Don't take it as 9.8 or anything, call it as 10, easy for the calculation. So you will get this as 1.5, correct? Now what is the unit for acceleration? Meter per second square. So you will get acceleration to be 1.5 meter per second square. Okay, this is the acceleration of the box. Alright, let's go another one. See, the second question is, okay, now as you can see in the figure, now it says a mass of 4 kg rests on a horizontal plane. The plane is gradually inclined until at an angle of theta is equal to 15 degrees with the horizontal. The mass just begins to slide. What is the coefficient of static friction between the block and the surface? Right? Okay, now carefully look at the figure. Carefully look at the figure. Now here, if you look at the figure, see that angle theta, if you can see angle theta, and this is the block which is sliding. Now if it is sliding, it has a force, correct? Right? See here, actually two forces act on the body. Very important, two forces. One is, so one which is going downwards, which is nothing but the weight. Okay, this is one force, and one more force is frictional force which is acting on the body. So two forces are acting on it. Okay, now see, any inclined plane, these are the two forces which acts on the body. Okay, now if you look at the figure, see, we have one force, see the weight is mg, right, mg which is downwards. Now resolving this into the components, remember resolving of a vector we did, same thing we are going to do now also. So when we have mg as the weight, so we resolve it into two components. One is mg cos theta, one is mg sin theta. As you can look at the figure, we have two things, right? Now if you look at this, see, the weight and normal are opposite, equal and opposite. So mg cos theta and normal are equal, and mg sin theta and the frictional force Fs, they are equal to each other. Okay, So that's what we are writing here. mg sin theta is equal to fs, mg cos theta is equal to n. Okay. Now see, as theta is increasing, okay, as theta is increasing, now what will happen? See, what will happen is, so as theta is increasing, now the frictional force also increases, correct? So the frictional force increases until it reaches a maximum. Then after that, if you increase theta, then the block will start sliding, correct? Right? This is the normal scenario. So if you take horizontal plane, you keep a block, okay, and then I start increasing the angle. Now, as long as the frictional force balances out the mg sin theta component, the body stays there itself. The body doesn't slide away. Now, once the maximum theta is achieved, like let's say 30 degree, from 30 degree it moves to 45. Now let's say it starts moving. So as theta reaches theta maximum, the frictional force Fs achieves the maximum force, correct? So we can write Fs max is equal to mu s into n, correct? Mu s into n. Okay. Now since we got this, let's try to apply the values whatever we have. Okay. Now see, tan theta, if you take tan theta in this case, so tan theta is nothing but, okay, see, tan theta formula was f by n, correct? So in this case it will be mu of s. Okay, tan theta is f by n, so mu of s. So theta will be tan inverse of mu s, right? We know theta is what? 15 degree. So mu s is nothing but tan 15. Tan 15 value is given to be 0.27. So we got the coefficient of static friction to be 0.27. Understood, right? So whenever you have any sliding problems, this is how we solve. Okay. Now see, quick recap of what we did in the problem. So you had one sliding block which was basically in an inclined plane. Now, as you increase angle theta, your force of friction also increases until after some point of time it starts moving. So that particular value we are considering here. Okay, so Fs max is mu s into n. Okay, so taking the mu s, see, tan of an angle theta is nothing but your mu of s. Okay, mu s, the coefficient of static friction. So you will get, so tan theta, if you substitute the value given theta here, you will get the coefficient of static friction. Understood, right? So these are few problems. Later on, you will see different types of problems in the frictional part. Alright.